Simple linear regression jump. I'm using my example of annual income of a bank customer and money spent last year on leisure travel. We are going to investigate the relationship between annual income and leisure travel spending. Use fit y by x. A response, y, is leisure travel spending and factor is annual income. We get the pattern, scatter plot for income and spending from the drop-down fit line. This is our regression line, and we have details down here. Summary of fit. See, R square is about 56%. That means 56% of the variations of spending are explained by annual income. In ANOVA table, sum of squares for the model and error for the regression and residuals. Mean square, which is the ratio of sum of the squares over degrees of freedom, and then the ratio of mean square model over mean square error, F ratio. And the F test, which determines the significance of the model, has a very small p-value. That means our regression model, is significant. In parameter estimates, we have the intercept and coefficient of x, or annual income. We have both estimates, but then the t-test that is done here, p-value of the t-test is very large, 86% for intercept. That means the intercept is not significant, but then our estimate of annual income coefficient, or the slope of the regression line, is significant, a very small p-value. If you right-click anywhere on this table, parameter of estimates, under columns submenu, we can add lower and upper 95%. And we can see the 95% confidence interval. Our intercept is between negative 461 and positive 547.7. That includes 0. This range includes 0. In fact, the t-tests we did here was testing our estimates against 0. If the intercept is significantly different than 0, or it's practically 0. With that large p-value, we did not find it to be significantly different than 0, and the confidence interval also shows that 0 is included in that. For annual income coefficient, it was significant. And the t-test was testing our slope, the coefficient of x, against 0 if the slope of the line is 0 or it's significantly different than that, and a very small p-value proved that it is significantly different than 0. We can see that reflected in the confidence interval. Between 95% confidence, our slope is between 0.018 and 0.03. We can go to linear fit drop-down and show the confidence interval visually. Also individual confidence curves or prediction interval. These lines show the 95% confidence interval and prediction interval for our estimates. We can plot residuals. Here under first residual plot, residual by predicted plot, those error points are scattered around the 0 line. A random distribution of these points around the 0 line means that we have no bias in our model. For example, errors are not concentrated on positive or negative area, or errors are not much larger on one side, on the larger side, or on the smaller side of the predicted value. Residual by x plot shows the graph of errors, residuals, against predictor, annual income. We can see the random scattered points around the 0 line. If these points are concentrated on one side, positive or negative area, or smaller, larger area, then we have a problem with the model. And normal quantile plot. The slope line here is the cumulative value of a standard normal distribution. And these points, plot of residuals, if they are perfectly on the line, we have a perfect normal distribution. Those two curves on both sides are 95% confidence level. If the residuals are plotted within these two limits, then with 95% confidence, we can say that the distribution is normal, almost normal. If the plot goes beyond these two lines, these two curves, then the distribution of the residuals is not normal. That's one of the basic assumptions of linear regression. We can go back to the linear fit dropdown and save predictors. It will save a column to our table which contains the prediction formula or the regression line formula. You can see that field is added. It has a formula, and the formula is the formula of the regression line. Now, by entering a value for annual income for the predictor, this is our X or predictor, we can see what will be the estimate for spending. For example, prediction for a person with $80,000 annual income will be this number, 2029.9. That's our estimate of spending according to the regression line.